In this video, we are going to create the visual editing grid for our editing mode.
Okay.
Now, up till now, we have utilized the concept of a grid in positioning our edit cursor. We've already got all of the snapping in place for moving the cursor around and making sure that it stays snapped based on the edit granularity. Now it's time to address the visual aspect of our grid. We'll use this edit granularity value in conjunction with our main renderer in order to draw an actual visible grid. The way we'll be doing this is by taking and reusing the note texture itself, drawing it with a more faint gray color to match the background, and drawing this over our musical staff when we are in edit mode. So, in order to employ this, we'll jump directly into our renderer. We'll jump over to Renderer Horizontal, and we will scroll up. Currently, we are inside of Renderer Horizontal near the end of the draw method looking at the edit cursor code. Now we're going to need to draw this edit grid behind the notes themselves. So we'll scroll up before notes. As a matter of fact, we'll actually scroll up before the start line. If we're looking here, we were drawing our measure and beat lines, then the start line. So what we'll do is we'll draw our measure lines, then we'll draw the grid, then we'll draw everything else. So we'll drop in here right before our start line, and we'll denote a section for our edit grid. Alright, let's talk about this grid and how we should space it and draw it. We're going to be employing a method that is very similar to our measure lines, because in the measure lines, the basic concept was we figure out a tick spacing in between the lines, and then we advance spacing by spacing, resolving a pixel value for each space, and then drawing at the resulting position. We're going to do the same thing for our edit grid. We're going to figure out exactly how many ticks go in a grid space, then we're going to resolve that using getStaffPosition, and draw a grid indicator at that location using our tick value. Now, one thing we will do in addition to this is rather than drawing a single line across everything, since we have a discrete note graphic that we're drawing, we'll actually have to draw that note once for every track. That means in order to draw position 0, we actually have to draw that position across tracks 1 through 8.
Okay.
So let's jump in and get started with some of these values. The first thing we'll need is, well, to make sure that we're in edit mode before we start drawing the grid, because of course the grid only applies to edit mode. So we'll begin everything with an if statement, checking our global state.editModeActiveValue. So if we are in edit mode, we will proceed with our grid drawing. Now the first value we're interested in is the number of ticks that are in a grid space. And we'll need to figure this out by calculating a whole note and then dividing that against the note value held in edit granularity. So let's drop down a local variable, and we'll call this variable ticks per grid. And this value will be equal to a whole note divided by our edit granularity. We'll find a whole note by taking song.quarternote and multiplying it by 4, then taking the resulting value and dividing that by our edit granularity. Now we need to look into the screen edit class in order to find edit granularity. So we'll drop it in place, and that will give us our ticks per grid. Now, we need to do the same kind of snapping that we had done before with our measure lines. As we're watching the cursor go by, we need to make sure that we find a value that is snapped to grid units. Now we have our tick value for our grid snapping, but we need to employ that snapping based on the song's cursor. Again, just for a review, we can look at our measure and figure out that we were getting measure ticks by taking the song cursor, dividing it by the ticks per measure, and then remultiplying it. So thereby we do some truncation thanks to the integer division, remultiply to get everything back to their original values, but we have a scenario where we will advance in whole measures. So we'll employ that here to advance in whole grid spaces. Let's make another integer, and we'll call this integer grid tick. And this value will be equal to song.cursor divided by the number of ticks per grid cell, then multiplied by the number of ticks per grid cell. So again, we'll employ some snapping so we have a cursor-based value that increases in terms of whole grid cells. Alright, now once we have this value, let's see what this is looking like. Let's take this value, resolve it, and draw it to the screen. For now, we'll draw just a single cell to make sure that the snapping is working right, and then we can spread that across all of the tracks. So that means at this point, we're going to make a vector2 variable called grid position, and then we'll use get staff position in order to find the position of our grid tick value. So grid position will be equal to get staff position, feeding in grid tick, and let's see, for now we'll specify 0 as we don't yet have track information, and we'll feed in the current song. So now with this position, we do need to make sure that these grid units pan along with everything else on our timeline. So we'll take this new grid position, we'll take its x value and decrement that by our scaled cursor, thereby employing our panning value. Alright, now that we have this positioned and panned value, let's draw it out to the screen. So we'll grab our sprite batch and tell it to draw. We will draw using the note texture. And let's drop down to our 6th overload just for a better reference on the parameters. And we need to feed in position, so we'll feed in grid position, null for the source rectangle. For our color, let's look at style colors, and let's pick the edit grid value. Now we'll have no rotation, so 0f on rotation. We'll have an origin based on this texture's origin, so that will be note origin. For a scale, we'll give a value of 1. Sprite effects will be none, and layer depth will be 0. Alright, that takes care of our draw. Looking at the end, looks like we're filling out all of the parameters. So let's load up our game now. Again, we'll be seeing only one single grid unit rather than a full grid, but let's make sure that the positioning is working. So let's jump into our game, into Song Editor, and load up a song. Now I'll move the edit cursor. It may be faint to see on the scaled version of this recording, but right here over the start line we have a faint gray grid marker right above the first hi-hat note. Now I'm going to play the song just to make sure that that note value repeats, indicating the snapping in place. So watching this out to the side here, we have this gray background note that is keeping up with the song in spaces of eighth notes, or whole grid units. So we do have our base positioning working, we just need more grid units. So what we'll do is we'll begin by spreading this value across all of the tracks. So that means before we jump into our grid position calculation, we'll create a for loop. Drop down 4, I'll hit tab twice to bring up the template for a for loop. We will use the index variable I, and we will loop through all of the available tracks. So that means we'll look into config, and we can use track names.count to give the number of tracks. Then I will move the closing brace of our for loop to after the code that's currently drawing our notes. Move some of that spacing back up. Now, this index variable I will indicate the current track that we are drawing. That means inside of our getStaffPosition call, we can look at the second parameter, which is track, and feed in I instead of 0. Now if we run the game, we should see a set of background notes all drawn vertically across the current grid position. And if we were to play, now we have a row of, or rather a column of grid spaces that follow the current song at the current snapping. Alright, that's working well for getting all of our track grid spaces drawn. Now we need to move over and draw more of these grid lines. We need to draw enough grid lines to fill the current screen. So we need to do, again, following the pattern we had in our measure lines, we now need to move all this drawing code into a while loop that loops until we get past the edge of the screen. So we'll create just such a loop here in the edit grid. We'll begin by moving the definition of our grid position variable outside so that we have the position already in place for the while loop. That means vector2 grid position will occur here outside of the loop, and will be set to an initial value of vector2.0. Then inside of our loop, we'll pull out the definition and simply use that variable. Now, we'll take our track drawing for loop and we'll place that inside of a while loop. So we'll say while grid position dot x is less than global state dot fixed drawing width. Then we need to continue looping and drawing. So that means as long as we're still on screen, run the for loop necessary for getting all of our tracks drawn, and then make sure that we advance our grid tick to the next grid space. And that'll be done outside of the internal for loop. We'll take grid tick, and we'll say that it will be plus equal the number of ticks per grid space. So that way, every time we draw a line, then we'll move to the next grid location and draw another. So let's test this out. Jump into our song editor, and we can see that we now have a grid being drawn on, well, at least half of the screen.
Right.
We're
so
still
now we have an idea where we could put all the notes, at least on one side, but we got to pull those back.
Exactly. Since we're starting at the beginning of the middle of the screen to draw our grid spaces, we're starting from the middle and drawing over to the side.
Very similar to what we were experiencing with measure lines.
Yep, and we're going to fix this using the same thing we did with measure lines. What we need to do is figure out exactly how many grid spaces we would need to move to get from the center of the screen to the left of the screen. And we'll call that shift count, and it will move everything over by that number of spaces. Now, in order to figure out how many grid spaces are to the left of the screen, we need to find the width of an individual grid space. So, after we have found our grid tick value, let's declare a new integer, and this one will be called grid width. And we'll set grid width to be equal to the number of ticks in a grid unit, ticks per grid, times our time scale. And time scale will convert that number of ticks over to pixels. Now, of course, time scale is a float, so we need to cast the result of this whole expression to an int, and then we can store it inside of grid width. Alright, now that we know how wide grid spaces are, we can figure out how many of them we need to move to get from the center of the screen to the left of the screen. We'll make another variable, and we'll call this shift count. Now notice what happens when we go to try to name this. Just pretend we were setting it to 0. We immediately have a problem where shift count is already in use because we declared it earlier when using our measure lines.
Mm-hmm.
And I like using the name shift count, especially since it's doing the same thing it was earlier. So I'm simply going to pull the declaration out. So we're just going to reuse the already existing shift count variable. I was just pointing out the declaration to say that this name does indeed already exist, and that's not why we're not redeclaring it.
Okay.
Alright, so with shift count, we'll find where our screen center is, and divide that, or excuse me, the number of pixels from the left side to the screen center, and divide that against our grid width. So we have screen center, which is going to be half of the width of 1280, our fixed drawing width. So we'll take that value and divide it by grid width, and that will tell us how many spaces we need to move to reach the left of the screen. So now that we know how far to go, let's take our main grid tick value and decrement it, subtract away from it by the number of ticks in one grid unit. So ticks per grid and catch just a little bit of spelling. There we go. Ticks per grid times shift count. And, I see what's going on. There was some initial misspelling with ticks per grid, which is now this.
Yeah, I didn't see that.
Yeah, originally when I typed this out, I named it tricks per grid. Let's hit F2 over this one, and we'll use refactoring to rename it so that we can pull out that R, calling it ticks per grid, hitting OK, and then that'll let us apply that to all the various places where we've been using it.
That's pretty funny.
Again, we would like to demonstrate the awesome value of refactoring.
Yes.
But, alright, so ticks per grid is now lining up. That means we're taking our current grid tick, moving that over to the left or decrementing it by one grid, one number of units in one grid space, times the number of grid spaces we need to move. So that will position our grid tick on the left of the screen, allowing us to begin at the very left and draw an entire field of grid units. So, let's try it out. Excuse me. Going into Song Editor, let's load up our song, and look at that. Now
Nice.
I have an entire screen filled with grid units. Now since everything should still have that panning value applied, we should be able to play, and our grid moves nicely with all of our notes. Then if we stop and move the edit cursor around, you'll notice that the edit cursor is snapping to those visual grid indicators. So now our drawing is working very nicely. So there's one more thing we need to address in this video, and that is, now that we can visually see our grid, let's put in the necessary input mode to our edit screen to allow us to adjust that grid.
Okay.
Let's put in the necessary code so we can change our edit granularity. So what we'll do is we'll jump over into our edit screen, and looking at our input modes, we're currently looking at note edit mode, so let's jump down right after note edit mode. So that should be right down here. Let's drop in a comment to indicate a section called granularity mode. Now, inside of granularity mode, we need to do a check just like we did in note edit mode and make sure that this section only applies to edit mode.granularity. So we'll do this with an else if statement, which takes in mode and sees if mode is equal to edit mode.granularity. If that's the case, we're free to begin applying button presses to the various functions of granularity mode. Now inside of granularity mode, all we're going to be looking for is the up key and the down key, where up will increase, you could say, I guess really it would be decrease the granularity, giving us a finer granularity, and down will decrease it. Or
I think it's the other way around.
yeah, looking at that, it's one of those where you multiply to go down and divide to...
Right, because you're setting your granularity by a type of note. So the higher your note, you go from like a quarter note to an eighth note, you get finer granularity.
Right, that's where the trickiness comes in, is a
Right.
higher note indicates a finer or smaller granularity.
Yeah.
So it's kind of like one is the inverse of the other. Alright, so focusing on up, let's change it so that up will go to a finer granularity. And let's see, looking at this, we need to put in a check. So if named input is equal to named inputs.up, then we can proceed with our granularity. Now again, with up, we're going to go to a finer grid, but that means we need to increase the note value, meaning if we were starting off on our default of an eighth note, the next one we want to go to is a 16th note. So we actually want to take the current edit granularity, multiply it by 2, and then that'll get us to the next finer note value. So the math is simple enough. We take our edit granularity and then say that will be times equals 2.
That is easy enough.
Now the thing we need to run into is we want to limit what the finest granularity is.
Right.
Because at some point we're going to cap out with our note value itself. We're not going to be able to set a granularity finer than the song's own resolution. Now, more importantly, we don't want to set a resolution so small that it makes our edit grid useless. What I mean by that is each of our grid markers themselves have a width, and there's only so many notes we can fit next to each other. At the moment, the note width has been chosen to accommodate a 30-second note, and we saw that employed in edit mode, or excuse me, in free play mode. So what we're going to do is make sure that this edit granularity does not go to a value higher than 32.
Okay.
Thereby making the 30-second note the note at which it will cap out at. So we'll take our edit granularity, and we'll set it to be equal to math.min. We'll say between these two, whichever is less, edit granularity, excuse me, or the value 32. So that means the moment we try to move to an edit granularity of 64, we'll instead cap out at 32.
Gotcha.
All right, let's take a look at going in the other direction, going towards larger note values, or excuse me, larger amounts of space denoted by lower note values. So let's put an else if statement together. This will be called, or rather we'll be checking named input See if it is currently the down key. And if so, let's say we were starting at our default eighth note value. Now we want to move to a quarter note, so we'll multiply edit granularity, or excuse me, divide edit granularity by 2. So we go from an eighth note to a quarter note, thereby giving ourselves twice as much spacing between the grid units. So we'll drop in edit granularity, and we'll say that it will be edit granularity divide equals 2. So simply divide it by 2, and then do another check because we don't want our edit granularity to reach 0, as that would cause problems when other things are dividing against our edit granularity. Now, a value of 1 for the edit granularity is going to mean a whole note's worth of spacing, and that is, we'll take that as the largest amount of spacing that we'll handle using edit granularity. So in order to employ this as a limit, we'll say that edit granularity will be equal to math.max between the value currently in edit granularity and the value 1. So what that means is the moment we try to divide to a number less than 1 and then truncate because of the integer math, so if we were to reach 0, we'll employ this method. We'll see that 1 would in that case be greater than 0. 1 gets retained and stored in edit granularity.
Okay.
And so that will make up our limit. Alright, with that in place, let's jump in and make sure that this mode is working. We'll jump into song edit mode, bring up a song, then we'll hit select a few times by hitting the enter button until we get to granularity. Now let's hit the up arrow key. You'll notice that our note step, our granularity, has moved from 8 to 16, and we have twice as many spaces being drawn for our grid.
Nice.
Or rather, we have spaces that are half as far apart. You'll also notice if we jump back into note edit mode, that as we move the edit cursor around, it is now moving by these finer 16th note spaces. So looking at our kick track at the bottom, you could see that we could now add twice as many kick notes if we wanted to. So jumping in here. So now we're free to make an even faster track for our kick notes.
Yeah, quickly getting to the point where we need a double bass pedal.
But looking at, let's check a few of the other granularities. So jumping back into granularity mode, we can hit it up once again, get all the way down to our maximum granularity of 32, so our finest value. And you can see at this point there's not enough space to put more grid notes together.
At this point, you definitely need a double bass pedal, or you have to be the drummer from Disturbed.
So let's check the other one. If we start hitting the down direction, we can walk back up all the way to our original value of 8, or even higher at 4. So now you have quarter note snapping, half note snapping, and finally whole note snapping. So here at 4/4 time, our whole note is going to also represent a measure. So we would move measure by measure. As a matter of fact, if we were to jump into note edit, you'll see that we'll quickly move off the edges of the song by moving at each of those limits.
Very cool.
So that has our snapping now working inside of edit granularity. Now there's one thing that would be very helpful when we're actually editing a song. Let's say that we move a few measures into the song, so now we really can't tell where we are. I mean, we can kind of tell that that's the end there, but as we're jumping measure by measure, nothing really changes.
Right.
So what we're going to do is we will draw the current measure number at the top of every measure. That'll make it a lot easier to keep track of exactly what measure we're editing. So in order to do that, let's jump back over into our horizontal renderer, and we're going to jump inside of the code for our measure and beat lines. The reason we're going to jump inside of the measure and beat lines is because we have this value of the current measure tick. Now that measure tick is of course going to be increasing in values of whole measures. So let's say our measure length was 384 ticks. That means we go to 0 to 384 to 384 again, or doubled. So the idea is that we can take that measure tick, or we can take this value, divide it by the number of ticks in a measure, and we'll have a value that will increase in 0, 1, 2, in accord with our measures.
Gotcha.
So we're going to draw our last piece of edit mode graphics actually inside of the measure code for this reason. So what we'll do is, as we're inside of our while loop, going measure by measure, right before we advance to the next measure, we'll drop in some code. And we'll also drop in a comment saying that it is here that we're going to place measure numbers. Alright, now we only want to draw these numbers if we have edit mode turned on. So we'll do an if statement, and we'll say if global state dot edit mode active. Then we will proceed with measure number drawing. Alright, let's do some division to find the actual measure number. So what we'll do is we will make an integer value. We'll call this measure, and we will set it to be equal to the current measure tick that we've been using to progress here inside of our measures, and we will divide that by the number of ticks in a measure. So we can look into the song to find ticks per measure, and that should give us a value in accord with the current measure that we're on. Now, let's see what this value is looking like. Now that we have a measure number located, let's put together some text. We'll make a string value called text, and we'll say that will be equal to measure number dot toString. So we'll get a string variable ready to go into a sprite batch dot draw call. So here, looking at our sprite batch, we'll make a call to draw string. We'll draw this using the small font. So we'll look into style and grab font small. Then our text will be fed in by the text variable. Our position will be fed in here using, let's see, what do we want to use for position? Well, at the moment, we already know where our measures are positioned. If we look up a little bit earlier, we had found this value called measure x, and we use that by deriving a screen position from measure tick. So, of course, that variable will still be in scope down here inside of our measure numbers. So we'll begin by simply dropping in a new vector2 so that we can use the current position of the entire staff in combination with our measure location. So, you know what? Looking over the notes and thinking about this, let's actually make this position variable as a variable, and that'll make it a little bit more clear rather than performing all of our operations inside of drawstring.
Sure.
So, as we've done now many times up to this point, let's make a vector2 called, let's say, measure text position. And we'll set this to be equal to a new vector2 of measure x for our x component and span y for our y component. The idea there is span y is the top of the staff, and we want to draw these numbers up right above the staff on the measure lines. Alright, so with this new variable, let's plug in measure text position into the position for our draw call. Now we're left with the color parameter, and let's simply use the beat mark color for the color for the text. So let's look into style colors. Here we have beat mark. Let's actually grab beat mark measure because it's a little bit brighter. Alright, that takes care of our draw call. And let's see what this is looking like so far. Going into song editor, we see that we have excuse me, everything being drawn below the actual staff. So looking at the very top, which makes sense, we have, looking over to the left, right below BPM 180, you can see that little character 1 right below it. As a matter of fact, that's a negative 1, but we'll address that here shortly. So at this point, we need to do some offsets so that we can move our text up above the actual staff. Now we're going to need to know the size of the text before we can move it. So let's make another vector2 in order to measure the text. So vector2, we'll call this text dimensions, and this will be equal to style dot font small dot measure string, where we can feed in the text value. So now that we know how large our text is, we can now offset it by adjusting the values fed into our measure text position, beginning with y so that we can see exactly where it's being placed. We'll take span y and we'll move up, so we'll subtract from that the height of our text, or text dimensions dot y. So now if we jump back into the game, load up our song editor, there we can see the measure numbers being drawn above the staff. Now there's still some stuff to tweak. Positional wise, we need to center these up because they're beginning looking at the start line. They're beginning a little bit to the right of the start line.
Right.
So it means we need to take the text's own width into account in order to center it. And you'll also note that over here to the left, once the numbers get over to the tempo indicator, they're almost touching the top text.
Yeah, they're a little bit snug.
So let's put a simple offset in place here by simply taking the resulting value for y and dropping it down by 3 pixels. Once again, that's the advantage to using a fixed height and width, is we can rely on individual pixel values for positioning. So there we go. So now we have the text moved down a little bit, and it fits better once it gets over to our status indicator.
So now we need to center these horizontally?
Yeah, let's take a look at that. We need to go to our X component, and we need to move this over to the left a little bit by half the width of the text. So we need to take our measure X and subtract from that a value of text dimensions.x divided by 2.
Half the width.
So, looking at this, there we go. Now we have the numbers centering up on the marker lines that they are associated with. All right, now looking at these numbers, they're a little bit off as far as the actual measure numbers. Our first measure is indicating a 0. Now, technically that's correct if you were looking at things in a zero-based mentality, but since we're going to present this display to players, it would make more sense to begin the players at measure 1 instead of measure 0.
Our players aren't programmers, so maybe they're not so used to zero-based counting systems.
So, and that's very easy to fix, where we can go in and take these numbers. Really briefly, let me jump back into the game and just show that they are continuing correctly, even though they're zero-based. If we begin playing, we see we do progress on to measure 2 and 3 and so on. So all we need to do is advance these numbers by 1. So once we have figured out what the measure number is, let's add 1 to that number. And that way we start at measure 1 instead of 2.
Okay.
Now one last thing I want to do is to make sure that we don't draw measures before measure 1, since in this case measure 0 is not accessible. We can't move the cursor negative anyway. So let's simply not begin drawing measures until we get to actual reachable measures. We'll do that by, once we figured out what the measure number is going to be, we'll use an if statement to check that value and only continue drawing if our measure number is greater than 0. So looking at this, we could probably snug that up just a little bit. And with this check in place, now we can see that we are not drawing a 0 off to the side, indicating a measure that we can't reach. So we start at the first measure, which is editable, which is 1, and progress from there. So now looking at our measure numbers going past, we're simply reusing the location values already acquired for the purposes of drawing the hit lines. And we're simply taking the value and drawing that to the screen. So again, just a nice help for anyone who might be editing a song, as now they can go in and record specific measure numbers. That way they can say, okay, on measure 5 we always want to have something happen. And then it's really easy to find measure 5 later in time. Alright, with that we have successfully created the visual snapping grid for edit mode. We've got our granularity input mode working nicely, and we have measure numbers drawing as needed.
Okay.
So with that, that is going to wrap up this video.